Hello, welcome to Evolving Code. My name is Naresha. In this episode, we will discuss something that I experienced during early part of my career. This is about Java. So the title is, does use of this make the code slow? So it was the first piece of code I wrote for production application in my first employment, and I received feedback from one of the senior developers. So I just wrote a sample code which will simulate the idea from there. So I have a class which is a person, and I have a field name, and I'm initializing this field in the constructor. I just have one constructor that takes name as argument, and I'm doing here this dot name equal to name. So this dot name refers to the instance field, right? And this name refers to the argument to the constructor. Is there anything wrong? So the feedback I received is that this dot name will be slightly slow in performance. For you to understand, let me show this piece of code. So the senior developer, he recommended me to write like this. So I can use a different name for the argument, so that wherever I use the variable name, it refers to the instance variable, and I assign instance variable a value in the constructor. In this case, I have called the parameter as value. Of course, the outcome would be same from both piece of code, but will the second part of code, which is on the right, will it make any difference in performance? Personally, at that moment, I didn't think his suggestion had any merit. But then when we argue, in reality, it's always better to come up with evidence and then discuss that, rather than just deciding the right thing based on who told the answer, right? So I thought about that at the outset. At least if you look at from a layman perspective, this may appear like slow because it looks like in the right side version you are getting some something which is present in the current room, and the left one maybe you have to go to another room and get it. That would be the very layman perspective to look at it. But if you have decent programming background, especially like pointer arithmetics using C, etc., you would have fair idea that all these are semantics abstraction on top of computers, and ultimately when they are converted to lower level code, these kind of model, what I mean is the object oriented model itself doesn't exist in CPU. It's just something which has been created to help the developers to simplify things. So usually when we talk about performance, the first thing that comes to our mind is why don't we do a micro benchmark and see which code runs faster. But in this case, you see the difference is very minute, so it's very hard to capture evidences based on the performance numbers. So good question we would ask is there any other way to prove that? Now if you know how Java works, Java code will be compiled down to intermediate code, which we call as bytecode, right? And bytecode is platform neutral. So in any machines, you compile your Java source code into bytecode, it should produce the same bytecode. Of course, provided you use the same version of Java compilers. So let's take that approach. Let's compile these code into bytecode, and then let's use a disassembler to understand what the bytecode looks like, and let's pick which code is going to be faster. Let's do it. So here we are. I have two terminals. Left side I have version 1, and right side I have version 2. So if you look at what I have, I just have Java file called person.java. Here also I have that. Let's see what is the content. The left side, we had the version 1 which I wrote initially. Then I have on the right side person Java, where this is the code which I modified to look as per his recommendations. Now first thing, let's compile both these using Java C and person.java. Now you would see that class file has been generated. Let's do the same on the right side also. Now you see both sides we have bytecode generated in the file person.java. Now let's use the disassembler, which is java p minus c, and I just have to give the class name, which is person. So I'm getting bytecode there. Let's do the same thing, java p minus c and person. You see, both cases the bytecode looks same. It has same number of bytecode, and we see no difference at all, right? So this dot variable name, use of that approach, does not make the code slower in any way. Both v1 and v2 have the same performance characteristics. So from the performance point of view, there is nothing wrong in using like this dot instance variable name equals some value. So this way we were able to come up with the empirical evidence to show that either version of the code is okay for us. Well, now our problem is solved, but if you are intrigued about understanding the bytecode a little bit more, I'll give you a quick overview. You wouldn't need much of a bytecode background. Basic understanding of Java would be enough. So initially you would see in line number 1, the constructor through invoke special command, constructor is of the base class is being called. Since the class person which I have created does not extend any other classes, by default java.lang.object becomes the parent of person. So in my person constructor, even though I did not call the parent constructor, by default Java compiler will insert that superclass constructor call. So you would see in 1 you have invoke special, which is calling the base class constructor. You see the it's calling java.lang.object. Init is for representation for the constructor, which will get the the newly allocated memory from the previous place. Now the next part is again this value, the newly allocated memory address, as well as the argument. Those are getting loaded onto the operand stack. Then put field is where the value assignment, this dot name equals to name, or name equals value what I wrote in the code, that happens. So if you see there are absolutely no difference here. The instruction at 6 remains the same, because the variable names what you give will be translated into address accordingly within the bytecode. Then constructor returns. Then below we have the bytecode for the getter, which is get name in this case. So that was a quick overview of the generated bytecode. If you are interested, I would be happy to do more videos on JVM bytecode. I hope you found this video useful. Thank you and see you in the next video.